Alright, so two variable inequalities, everyone. Basically, what this is introducing is the idea of graphing inequalities. Okay, so graphing inequalities basically is taking an absolute value, no, not an absolute value, we just talked about that, but we will introduce that again, is taking an actual equation and introducing two variables to it. So y is greater than negative 3x minus 2. Okay, so normally we would start at negative 2, okay, and you would have your dot, okay, and then you would go down 3, 1, 2, 3, hopefully not as horribly as I just did, and you'd make your next dot, and then you would make your line. Okay, now here's the thing though, is that when you make your line, we are going to want to make it dotted as soon as possible. Okay, now if you're making straight lines, the reason why we want to include dotted is because of this little inequality sign here. Okay, now this inequality sign says everything greater than. Okay, it does not mean also including equals. So if you remember when we graphed inequalities, if you had something greater than something else, it couldn't be equal exactly because of the law of trichotomy. But in this case, we're going to not include everything on the line. So how do you represent that when you've already accidentally drawn a straight line? You can put lines through it to represent we're not including this as well. I like to do this just to work with it. Okay, so graphing is just like normal. Alright, now, as you guys know, I'm a fan of Desmos. So let's go new blank graph. Okay. Alright, so when we're graphing that stuff, y is greater than negative 3x minus 5. Okay. Alright, so in this case, if you take a look at this one, oh, I think it was minus 2. Yeah, it was minus 2. Okay, if you take a look at this one, now there's a shaded part, and what the heck is all that? Well, this is technically the answers, every single one of these points, and there is an infinite amount of them that will fulfill this inequality and make it a true statement. So for example, 0, 0 will fulfill that statement. So if I take 0, 0 and plug it in, okay, I get 0 is greater than or equal to negative 3 times 0 minus 2. Okay, and if you look at that, that is 0 is greater than, what's negative 3 times 0 is 0, and 0 minus negative 2, it's negative 2. So 0 is negative 2. So that makes that a true statement, a true equation. Okay, so since that's true, that's a point that's there. Now, an interesting thing is you have to go back to your geometry to know this, but if something's included in a plane, then all those other points in that plane are included. So it's not a most common knowledge type of proof, but it actually is a proof, and there is a pretty good proof for it. Okay, but basically, if this point is answering this as a true statement, then every other point on this side of the boundary line is also going to answer a truthful statement. Okay, now if I pick something over here, like let's say the point 0, negative 4. So I plug in 0, negative 4, and I get, oops, quotations, negative 4 is greater than negative 3 times negative 4, or 0, minus 2. Okay, so that's that statement so far. So we get negative 4 is greater than, well, this side is going to turn all into negative 2. Okay, and so I get negative 2 right there. Some of you guys are going, oh, well, that is true. 4 is greater than 2. So you would say, why isn't that true? Well, here's the thing. Negative 4 is not greater than negative 2. Okay, so since this is a false statement, everything on this side of the boundary line would not be included in my answer that could make this a true statement, okay? Alright, and so that's basically how it works, and that's where the boundary line comes into play, and that's where the actual shading comes into play. Now if I change this, will that change some of my answers? Let's go negative 2. It doesn't change any of them for this circumstance, okay, which is kind of nice. What if I change this to a -4? Oops. Let's go 4. -4. What if I try to move it down? Well, that still keeps this all working out great and dandy and stuff. Okay? So no matter how you change it, some of the points are going to be true for a lot of different equations, okay? All right, so this is a lot, graphing inequalities is a lot different because you're actually graphing half a plane. Not just a line anymore, you're graphing half a plane. Okay, and as you can see in Desmos, they have a really nice setup to where everything's dotted already, so you don't have to worry about that. Now what if you go, oh man, I graphed it, I want an actual solid line because I want greater than or equal to, just go next to the equals or the greater than sign and type equals and it'll add it for you, and now you have a solid line. So there you go. Okay, now I do want to go back. What if I picked a point that was on the dotted line? Would it fulfill this statement? So let's test it and plug it out. Alright, so -2 is greater than -3 times 0 minus 2. Okay, well once again that right side is going to turn into -2, so -2 is greater than -2. Now if you notice, that is not a true statement, that is actually a false statement. So this helps support the fact that anything on the line is not included in my answer. Whereas if I did an equals, okay, alright, now I expanded my statement to be -2 is greater than or equal to -2. Well, it is equal because it is -2. So this would turn from a false to a true statement, which makes sense because now this is a solid line. Okay. Alright, now one huge thing that you guys do need to know is that you can actually combine both absolute values and inequalities. You'll just be shading outside of the letter V. Okay, but those are called half planes still. So y equals absolute value of x. Okay, that's pretty normal. That's our usual normal graph. But let's say you put greater than. Now it's going to be everything inside. Okay. What if you had less than? It's everything outside. What if I had less than or equal to? Now it's a solid V instead of a dotted V. Okay, so there's a lot of great things that can happen with this Desmos that you can do with this stuff. Okay, now can you overlap some stuff? Yes, you can, and we will talk about that at a later time. But for right now, your guys' two variable inequalities, you do need to know, be able to know how to use Desmos, but you do need to be able to understand where it comes from. Okay. All right. Other than that, you guys have a great day, and I will talk to you later. Bye.